Okay, so when we think about physics, we think about these four things, right? If you were to divide physics into four categories, you can divide them into classical mechanics, quantum mechanics, special relativity, and quantum field theory. So we will be dealing with classical mechanics. And in order to do classical mechanics, we first have to do vector analysis. So what is a vector?
It's a magnitude and direction.
Excellent. It is anything that has a magnitude and a direction. Speed is a scalar. Velocity is a vector. Vectors are written with an arrow at the top. You can add vectors. A plus B. You can subtract vectors. A minus B. When you add vectors, say A and B, addition makes it like this, and the resultant is a vector that goes from the tail of this to the head of the end. Subtracting vectors mean A remains the same, B becomes a minus B, the resultant vector becomes this. Joining the tail to the head of the last vector is called the head to tail rule of vector addition. You can multiply vectors. When you multiply vectors, you can multiply them three different ways. You can multiply a vector with a scalar. That means 5 times A means that the vector will become, the magnitude of the vector will become 5 times, whereas its direction will not change. You can take a dot product of a vector with a vector, or you can take a cross product of a vector with a vector. When you take a dot product of 2 vectors, it will be written like this. And a dot product results in a magnitude A, magnitude B, cosine of theta. For a vector cross product, the 2 vectors that are being multiplied will either become A times B equal AB sine theta, or we can also write A times B as a matrix I, J, K, AX, AY, AZ, BX, BY, BZ. Note, I am not going into the details about everything, right? Assuming that you guys have all done vectors before. It's a very, very brief introduction. This is called a scalar product This is called a vector product. And the reason it's called a scalar product is because the result is going to be a number, like 6. This is called a vector product because the result will be a vector, like 5i plus 2j. I'm just giving you that as an example. We also did that thing in Newtonian. Do you remember this? I, J, K. And we made a happy face for this one. And if you do it the opposite, I, J, K, going the other way around, you get minus signs. Oh, I should probably make this come down then.